This is question 7 for the 2016 summer exam for mathematical methods. So the first part of question 7, we define a linear transformation of cubic polynomials to 2 by 2 matrices by this mapping, and we want to determine t of this polynomial, and then give an example of a non-zero vector which is in the kernel. Then we also want to determine R bases for the kernel and the image of this transformation. And in part B, we suppose that matrix A is similar to B, and we're given that if A is similar to B, then A is P inverse BP, and then we want to prove that all matrices similar to an invertible matrix are also invertible. Okay, so for 7 part A, we want to find T of this vector here. So you can see that A0 is 1, A1 is 2, A2 is 3, and A3 is 4. So we just substitute those values into here, and we get T of this polynomial gives you the matrix -1, 0, 2, 1. Now, we also need to find a non-zero vector which is in the kernel. Now, obviously 0 is in the kernel because T of 0 is equal to 0, but we want a non-zero polynomial. So if we take T of 1 plus x squared plus x cubed, then you can see that A0 is 1, A1 is 1, A2 is 1, they're all 1, and you can see straight away that all of these terms here will go to 0. So T of this polynomial would give you 0, 0, 0, 0, and therefore 1 plus x squared plus x cubed is a non-zero vector which is in the kernel. For part 2, we want to determine R bases for the kernel and the image. So we'll look at the image first of all. So if we look at T of a general polynomial, then this is what we get in the image. So in the image we have matrices of this form. So we can rewrite this matrix in terms of these 4 matrices. So we have A0 times this matrix plus A1 times this matrix plus this is A0, this is the A1 terms, this is your A2s, A3s, and that's your A2s. So we can rewrite this matrix is spanned by these 4 matrices, which are multiplied by A0, A1, A2, and A3. But notice we do not put A0, A1, A2, A3 into here. We just know that this general matrix is spanned by these 4. Now the next question is, how many of these matrices are linearly independent? So we can see that, for example, these 3 here are all linearly independent, and this matrix here is a sum of these 3. So these 3 are linearly independent, and this one is dependent on the other 3, so we can get rid of this matrix here. And that leaves us with these 3 matrices which span the image set here. Okay, so these are linearly independent, so therefore the dimension of the image over T is equal to 3. If you wanted to prove this more formally, you'd have A alpha times this plus beta times this plus gamma times this is 0, and then trivially alpha equals beta equals gamma equals 0. So they are linearly independent. So therefore a basis for the image is equal to these 3 vectors. Now we look at the kernel. Now for the kernel, we want, if the polynomial belongs to the kernel, we want the matrix here to be 0. So we want A0 minus A1 to be 0, A3 minus A1 to be 0, and A2 minus A1 to be 0. Or, in another way, we can say we want A0 to equal A1, A3 to equal A1, and A2 to equal A1. So if we put those into the polynomial, then our general polynomial is given by P of x is equal to A0 is A1, A1 is just itself, A2 is A1, and A3 is A1. So we can express everything in terms of A1. So a basis for the kernel of T is just one vector. It's just one polynomial, 1 plus x squared plus x cubed. So that's the basis. So the dimension of the kernel is just equal to 1. And then finally we have part B. So we're given that A is similar to B, so we can write that A is equal to P inverse BP, and B is, and we want to show that we have invertibility. So if we take the inverse of this, then the inverse of A is equal to the inverse of all of this. And then if we remember how we take inverse, we reverse the order of these three. So P inverse BP inverse is equal to P inverse times B inverse times P inverse all inverse. So it gives you P inverse, B inverse, P inverse, inverse, which exists as P and B. They have inverses. So therefore, that does prove that all matrices similar to an invertible matrix are also invertible. And that concludes the solutions to question number 7.